Okay, this is the video for CPE 301. This is a design assignment 4B, task 1. It's the operating the stepper motor using the ADC control value from potentiometer. So, okay, and as usual, I'm going to walk you through some code real quick. A lot of this is basically just mainly a timer setup. It's one of the most crucial parts of what's going on here. So, well, and in connection to that setup of the ADC, right? So again, last time, as we looked before, we set up the ADC values. We look at that process here. Let's go back a second. This is set up to use same process. So 8 pin 0 or PC 0, and the typical setup here, and then does our read value like this. Takes it, about an average of 4 samples of that. Okay. All right. The remainder of that, after the initialization, some step time, let it get rolling. We set up timer 1. Okay, so we set up a timer 1 to be able to use to be able to pull the value that's currently being set, and then use that value to be able to in other words, it sets the period between these different steps. So again, let's probably step into this to help make some sense. So set up timer 1, we use the timer 1 interrupt, that value. I initialize it, but then actually keep loading it in every time we take a read from the ADC. So meaning we basically we set a scale to produce an RPM value, and that's going to set the period between changing the values on the overall on the motor's operation. Okay, so these, right? So every time the CTC mode sets timer 1 to fall into its ISR, its interrupt routine, we get this. The step, basically, or the value that's being currently held in port D, or the position value that's being sent to the stepper, is being changed. So E, C, D, and these relate to basically 4 binary numbers that's changing the magnetization, or rather changing the poles that are currently being held high inside the stepper motor. So our scale is from 1699 to 40,000, meaning that's about the scale value that's being used to be able to produce basically an average of 850 microseconds up to 20 milliseconds, which is a pretty nominal or typical periods to be able to actually operate the motor correctly. So let's look at this real quick. So here's the actual setup. Okay, so this is the motor driver. I actually obtained some from somebody else. The one I had, this one was broke. Pin D was not operating correctly, so you only had 3 of the poles operating instead of 4, and that actually, your motor won't move. Maybe slowly. You might get some small iteration, but it wasn't enough. I also changed the number of steps included. The class recommended 4, maybe 6. I had stepped it up to 8, and I got better performance. So again, these values just relate to binary numbers in between, so I can show that too. Let's see, where did that go? Let's see if I can find that paper in a minute. And it showed this. Oh, here it is. Here we go. Can't find it. Oh well. Oh, here it is. Here's the chart. So these hexadecimal numbers actually relate to a binary number. In this case, this is the 4. I changed it up to 8 and get these set across. And these relate to the actual pins on the board. If you look here, relates to the 4 output pins. These flashing lights you see here. These are the changing of the pole values over time. Okay, that's where these come from. And that's what you see on the chart up there. Schematics, how lined up. So that actually, even though this one was the one that was broke, both of them had almost the exact same setup. A little bit different chip, but it's okay. It gives you the desired output. Anyway, that's tied in. I actually pulled in power from a power supply, and then pulled it in for use here. Connected all the grounds, and then here's our actual motor. Right now, it's turning at a certain rate. All right, so let's go here, and this is our potentiometer. Same setup, 5 volts ground, and our data out pin, which is being connected to PC0 over here. Let's go ahead and turn this now. I'll switch hands so you can actually see what's going on. If I change this, I'm going to decrease the period, so it should go faster. See, look at that. It works really good. Look at that. It's one direction. It's okay. Okay, I'm now going to go ahead and step that up. You can see that as I am increasing the period between the step changes, it decreases our time in here. So I'm going to go ahead and go all the way to the top value. That's as slow as she goes. It's pretty slow. It's dead as a doornail. Slow. Looks good. Oh, one more time. I like it when it goes fast. Go faster. You see there's actually been a time or delay it took to be able to go in and actually take an ADC value. So the interrupt is occurring in between, right, between reading and stuff like that to make sure you get a correct measurement out. So you have a little bit of play in there that goes on. But of course some of that stuff is clock cycles to get completed, which is pretty good. But either way, you got a little bit of delay in there to get that measurement done correctly. So okay, that's it. That's design assignment 4B, task 1. Thanks for watching. This is a quick continuation. I forgot actually to make an addition here, so I was able to throw in the logic analyzer in connection to the board, so I can actually watch the iterations as they change. In other words, the pole changes. So let's go ahead and open that up now. So if you can see here, you can see these are the pole changes. I'm going to go ahead and just simulate this one more time. It's like a 5-second sample or something. So there we go. Perfect. So this is on the fast. This is actually the fastest setting, fastest rotation. So, but this is the changes. But there's really small incremental. But as you zoom in, you can see the spatial amount of time that occurs between them. So that's for the rotation, making sure the motor rotates correctly. So that's it. Looks good. This is a quick continuation. I forgot actually to make an addition here, so I was able to throw in the logic analyzer in connection to the board, so I can actually watch the iterations as they change. In other words, the pole changes. So let's go ahead and open that up now. So if you can see here, you can see these are the pole changes. I'm going to go ahead and just simulate this one more time. It's like a 5-second sample or something. So there we go. Perfect. So this is on the fast. This is actually the fastest setting, fastest rotation. So, but this is the changes. But there's really small incremental. But as you zoom in, you can see the spatial amount of time that occurs between them. So that's for the rotation, making sure the motor rotates correctly. So that's it. Looks good.